Hey everyone, thanks for joining. Today we'll be taking a look at what is going on at the edges of plate boundaries. If you haven't checked out our last episode on the layers of the Earth, make sure you do, as it will give some extra context to understanding what we run through on today's episode of
Geography Rocks.
So what is actually happening at plate boundaries? As the tectonic plates, known as the lithosphere, sit on top of the flowing convection currents of the mantle, known as the asthenosphere, the movement within the mantle slowly moves the lithosphere above. This causes the tectonic plates to drift. As they move and drift in various directions, they scrape, crash, or separate with their neighboring plates. The Pacific Ring of Fire highlights what then happens at the edges of plate boundaries. We see earthquakes and volcanoes. But depending if they scrape, crash, or separate, we will see different outcomes. The scraping, crashing, and separating of plates leads to 4 different plate boundary types. Destructive plate boundaries, otherwise known as convergent destructive. Constructive plate boundaries, otherwise known as divergent. Conservative plate boundaries, also known as transform, and collision plate boundaries, also known as convergent collision. Check which exam board or system you use to ensure you're using the correct vocabulary. Firstly, looking at destructive plate boundaries. 2 plates converge and collide with one another. One plate is oceanic crust, such as the Nazca Plate. The other continental, such as the South American Plate. As oceanic crust is more dense than the continental crust, when they collide, the denser oceanic crust sinks and is forced downwards underneath the continental crust. This process is called subduction. Make sure to make note of subduction, as it's important geographic vocabulary you can use in your answers. As the oceanic crust subducts downwards, it's forced deeper and deeper down towards the mantle. The pressure begins to increase, as well as the temperature. This increase in pressure and heat on the oceanic crust will start to destroy the plate, melting and turning it from solid rock into magma. This process continues over thousands and millions of years. Magma builds up deep underground, and when you fill a container with too much of something, it explodes. The magma finds the path of least resistance, upwards through the crust, and explodes in a violent volcanic eruption. You would also expect to find violent earthquakes along destructive plate boundaries. As the plates collide and subduction occurs, seismic energy is released through the friction and scraping of the plates. Next up, we're taking a look at constructive plate boundaries. Here we have 2 tectonic plates, diverging and moving away from one another. As the plates separate, this creates a gap in which magma can rise through, leading to minor volcanic eruptions as it oozes up through the crust as lava. We also have minor earthquakes at constructive plate boundaries. The image simplifies the gap between the plates, but picture a Velcro-like tangling of melded rock between the plates. As they pull apart, this rips the rock apart, sending out seismic energy leading to minor earthquakes. An example of a constructive plate boundary is the North American Plate and the Eurasian Plate. As they separate, magma can rise up through underwater volcanoes. Over millions of years, these volcanoes can rise up through the water and create an island. And that's exactly what happened with Iceland, in the middle of the Atlantic Ocean. Only rising up past the ocean surface roughly 16 to 18 million years ago. A blink of an eye in geological timescales. To put it into perspective, Iceland didn't exist for another 50 million years after the dinosaurs went extinct. Our next plate boundary type is conservative plate boundaries, also known as transform plate boundaries. Here we have 2 plates moving side by side and scraping and snagging alongside one another. As neither plate is moving apart, creating a gap for magma to rise through, and no subduction occurs, creating new magma. We won't see volcanoes at a conservative plate boundary, but the friction of continent-sized plates scraping together will build up a great deal of strain energy when they snag. The plates continue to move, the pressure continues to build, until one day the plates will slip past one another, releasing the built-up energy and sending it out in seismic waves leading to violent earthquakes. The western coastline of the United States is an excellent example of a conservative plate boundary. The Pacific Plate and the North American Plate move side by side along the San Andreas Fault Line, leading to powerful earthquakes across California. The final plate boundary type we'll be looking at today is collision plate boundaries, also known as convergent collision. Similar to destructive plate boundaries, 2 plates converge and crash into one another. The difference this time is both plates are continental crust, as they are the same type of crust. Neither is denser than the other. Because of this, no subduction will occur, leading to the plates crashing and crumpling upwards instead. This leads to the land buckling upwards, creating fold mountains. We see a collision plate boundary at the Indo-Australian Plate and the Eurasian Plates. As these plates collide, no new gaps are created for magma to rise through, and no subduction occurs creating new magma. resulting in no volcanoes forming along this plate boundary type. But as these continents collide, the seismic energy released leads to powerful earthquakes across the region. The buckling and folding of the crust at the Indo-Australian and Eurasian plates leads to the tallest mountain range in the world, the Himalayas, which continue to grow each year. Thanks for watching this episode of Geography Rocks. Join us next time for when we'll be looking at the impacts and responses to tectonic hazards, when countries at different levels of development have to live with and manage these hazards.
Don't forget to like and subscribe.